Hey everyone, welcome to our webinar about what they didn't tell you about implementing machine learning in practice. Great to see you all here today. And joining me today are Łukasz Grzybowski and Willy Picard. I hope I'm pronouncing that correctly. Łukasz Grzybowski from STX Next and Willy from Egnyte. How are you doing today, guys?
I'm a bit nervous, but in general, I'm fine. Thank you for asking.
Yeah, I'm very excited, and I would like to take the opportunity to thank you for inviting me. So thanks again. Looking forward to the discussion.
Well, preparing for this has been a genuine pleasure, let me tell you that right off the bat. And yeah, I like how one of you said nervous, the other said excited. Whenever I feel nervous, I like to just tell myself that I'm excited instead. That usually works. So I'm very excited to be with you here. We have a lot to show, all of you guys attending. So guys and gals, I should say, all of you folks attending. So let's get right into it. So first of all, a few words about our speakers and why it's, well, worth staying at this webinar and worth staying until the very end. So obviously we'll be tackling the area of machine learning. So let's talk a little bit about the machine learning experience. Willy, do you want to start?
Yeah. So I'm Willy. So currently the head of the machine learning department at Egnyte, or team, should I say. Before this, I've been involved in some academic research, working about 15 years at the university. Then I moved to Samsung, where I also did some work related to machine learning. Now I'm at Egnyte for 3 years already. And in my team, we are basically helping to develop the product we do have at Egnyte by providing new machine learning-based solution. So the product basically we have at Egnyte allows, on one hand, companies to share the files, but also to manage these file repositories. So we do use a lot of machine learning in order to somehow analyze the content of the files or try to detect anomalies in the behavior of the users, try to extract different name of people from the content that we have. So a bunch of different technique that we are using in the product. So that's basically me and my current role in the pill.
Yeah, and that's one thing that I find really interesting is that you have one product, deep experience with it, and a lot of functionalities there that are actually based on machine learning. On the other hand, we have our very own Łukasz Grzybowski from STX Next. How about your experience, Łukasz?
Yes, currently I'm head of machine learning and data engineering at STX Next. During my more than 9 years of career, I had opportunity to gain knowledge and experience in areas such as telco, insurance, banking, e-commerce, classifieds, and software house, of course, as well. Now I'm responsible for delivering a wide range of product to our clients in various industries and sizes. I had also opportunity to run my own company for a while.
Okay. Yeah, so what I like here is that, dear watchers, what you're getting here is basically the best of both worlds. You got Willy, who's got deep experience with one product. On the other hand, Łukasz has this kind of broad experience with a bunch of products from various industries, as you've just heard. Speaking about watching and hearing us, it would be great if you could leave a comment now, if you can see us and if you can, if you're getting us correctly, because on a technical level, we want to make sure everything is working right before we start giving you all of the knowledge and information that we've got prepared for you today. So I know there's a bit of a lag. Leave a comment, let us know everything is working. I can see already quite a few people tuning in, so that's very nice. And we'll move on right into our agenda. Before that, a little bit of history about why we're running this webinar. There's a lot of educational material about machine learning out there, but we noticed that a lot of it is geared towards developers and engineers and programmers about how to write your first machine learning programs and basically how to get started with that. However, there's not a lot of material. I can see a lot of your comments already rolling in, so thanks for that. Not a lot of material when it comes to the work of a manager or project manager who is tackling a machine learning project. And that's the kind of person that we want to help today. Don't get me wrong. If you're interested in machine learning at any level, you'll probably get some value out of this. Definitely, you will. But especially if you're a manager, you'll learn how to just tackle the unique elements of machine learning projects. The timeline is a little bit different. The steps you take are a little bit different, and the expectations can be a little bit different too. So we'll tackle the agenda that you see here, and at the end, we're going to have a Q&A session. You can ask questions throughout the webinar, no problem. If something is really, really relevant to what we're saying right now, we'll tackle your question right now. If not, then we'll just tackle your questions at the end of the Q&A session. So everything that we'll be presenting today is based on this roadmap that you see here. And we're going to start with a big question, whether you should do machine learning in the first place. And that's something that Łukasz taught me a long time ago, that this is the first question you should actually be asking, because machine learning, despite the hype, it is not the solution to all possible problems. We'll tackle that first, then we go into looking at the business problem that machine learning is going to solve, a lot about data and what to do with it to ensure a successful machine learning project, and then how to train the model and how to test the machine learning model. That last bit, only if time allows, we'll cover it, because we have an hour scheduled for this. And we also want to answer your questions, so we might have to leave model testing for the next time. That all depends on how we do with the rest of the content. And I should stop talking now and just get to the point already. All right, so thank you again for your comments. I can see comments on YouTube from a bunch of people. Thank you, Marta, Piotr, and Dominique, for your comments. Great that you can hear us. Let's get started. So the first big question, should you use machine learning or not? How do you start answering that as a manager?
Yeah, so from my perspective, as already Jakub said, machine learning nowadays is a really, really popular topic. It's kind of buzzword, fortunately or unfortunately, and only part of the community really understand how to handle it and what is related to that. Of course, if it's applied correctly, the benefit is clear. It could be a killer feature on your platform. It could be the main competitive advantage. It may be a crucial growth driver for your company. However, honestly, only the part of the community knows that this is really long, time-consuming, and complex journey. So you need to really think about that at the very beginning. You will for sure meet the problems and issues that you didn't meet before. And the development, the machine learning development, is quite different. We have a few totally different stages comparing to for example, the web or the mobile development. So should I do that? Let's think a minute. If it's possible to define the set of rules or to program the business logic to solve your problem, you shouldn't think about machine learning at all. However, if it's not totally possible to explicitly program the solution, machine learning is probably for you. However, it's totally fine to decide to not incorporate machine learning into your product, into your platform. It may save your time and money for sure. However, from my perspective and my experience, each project is usually really unique, and you need to analyze it separately.
Okay, so Łukasz, Willy, do you have any examples of particular cases where machine learning would be a fit or wouldn't be a fit?
Yeah, I got actually two examples. The first one is an example where we first thought about using machine learning, and then we decided maybe that's not worth it. And the case was the following. We wanted to predict the name of the folders that the user are creating. And so you can imagine if it's like, you have folders like January, February, maybe you can predict that the next is March. So our first idea was to reach for machine learning to do so. But then we figure out that with a simple set of rules, like taking care of months, taking care of dates, of numbers, or sequence of numbers, you can cover almost 90% of the cases that we will be able to address using machine learning. So we knew how we can program it, right? We knew the algorithm that we can explain the rules. So then we decided not to go for ML. Another issue we had was the idea of detecting when somebody downloads too much files. And here, the first idea was, well, let's do something simple. If it's above 100, then it's too much. It's a very simple rule. then we figure out it does not work. So we tried to complicate it by adding more rules and adding more and more and more rules, to the moment where we could not explain anymore how the thing was working. And that's the moment where we took the decision and, okay, it's time for machine learning. And now this is something we had in production. It's a big success. So another way to rephrase this, and I like this very sort of sentence in the pill, is that if you are able to explain how to solve your problem to your grandma, then you probably don't need machine learning.
Okay.
If you can, maybe look for machine learning. Yeah.
Okay, so if you can program it in a traditional way, or if you can explain it to your grandma, then machine learning might not be the way to go. But on the other hand, if you find yourself writing more and more rules, it's getting more and more complicated. Maybe it's time for a model. Did I get that correctly?
Correct, right. That's exactly the idea, yeah.
Okay. Yeah, so those are the things to keep in mind. Łukasz, anything to add here?
Yes, I think that I have also something that even if you decide that, or you know that machine learning could be applied, there is at least 2 more points to check. First of all, you need to check whether the effort needed to build the solution corresponds to the potential benefit. If not, then no sense to do that. And the second, a bit maybe similar, the feasibility check. If you have extremely limited resources like team, time and money, and the problem is really big, and for example, big companies, big players like Google or Facebook have spent years on that, then probably, and you would like to do the same in 1 year or half a year, it's probably not a good idea to start that project.
Okay, yeah, so you should be prepared for a bit of a bigger investment here. I just wanted to address one comment here that Christian asked on LinkedIn, will there be a replay? Oh, I see that our Adam already is on the case. Yes, there will be a video of this after this is finished, but the only way to get your individual questions answered during the live stream is if you stay and if you ask the questions in the chat, so I encourage you to do that. Anyway, so is that all about choosing machine learning or not, or was there anything else you guys would like to add?
Just one thing to add on what Łukasz just mentioned is that there's already a lot of available services that are provided by Google, Amazon, or a lot of different platforms of this kind, which you can basically use that provide machine learning certain type of problem are solved. So if you don't want to build your own, I don't know, object recognition system in pictures, you can reach for Azure, you can reach for AWS, for GCP, and they do have this kind of thing already. That can be another alternative too.
Okay, yeah. So also look into existing solutions. So here were a few questions that you can ask yourself to decide whether machine learning is for you. And obviously, for the rest of the presentation, we're going to assume that you answer that yes, your problem is complex. You have the resources, and you would like to try to solve this problem with machine learning. So let's move on to the next stage then on our roadmap. Well, the next stage really is that you need to, well, you're entering the whole machine learning life cycle. So guys, would one of you want to explain what's happening here?
I think I can take this one if you don't mind, Łukasz. So the first thing, if we want to solve a problem using machine learning, we need to understand how this problem is defined. So that is step 1, which is basically this business understanding step. So here you define the specification, what you are trying to solve. Then, because machine learning is based on the idea that you can build a system by providing some examples instead of coding the whole thing, you need to have data. So that's the step 2, where you need to gather appropriate data to be sure that you have the examples that you will use then to build the solution. When you finish to gather the data and they are appropriately processed, so they are good data, if I can say so, the next step is to build the model. Build the model means that you will learn from the data the solution that you want to implement, basically. So you will send all the data as examples to your system, and then you will learn what is the appropriate solution, how the system should answer. And that's the way you're training the system. When you do have the model, so the model is the part of the software which is able to answer to different questions, then you need to deploy this. So some additional steps so that you know that it will be monitored appropriately, that you will have all the safeguards, that the services are working, a lot of stuff related with putting software in prod. And the last element is basically maintaining the whole thing, because if you build something with data that you have today, you might face a problem in 2 years where the data are different, right? Or you need to be sure that the model is still valid. So that's the next step, which may contains either retraining the model, or if it appears that the model is not working anymore, maybe you need to come back to the first step. So that's why we got a circle. It appears that the model is not working, then you need to, again, redefine what is the business problem that you are trying to solve. And then the loops goes on.
Yeah, it's like with any sort of solution, it might not be permanent. And the way you explained this life cycle, and when we prepared for this, my understanding that I gradually built was that, seems like we lost Willy for a moment there. Probably misclicked. But anyway, as he returns, I just wanted to, yeah, there you are. Come on back. Hey, Willy, welcome back.
Thank you.
Yeah, so just wanted to say that, it really emphasizes the learning part of machine learning. You're not explicitly programming a piece of software, but rather you're giving it good examples, enough data, enough examples that it learns instinctively, or, in a way, what a good result looks like, and then you give it new data, and it takes a test, in a sense, of whether it learned correctly. So there's a lot of overlap between traditional human learning and machine learning here. Anything to add to the life cycle, Łukasz?
Yes, maybe I would like only to add what I always said. In my opinion, this is, as Willy said, this is never-ending story because of this cycle. And when we have invalid model, this is something that is really different than other development part. Model that works may stop working in the next years, and we need to rebuild or tune it. So this is really unique part, and we need to have in mind that and that's the reason why it's never-ending story, or it could be never-ending story.
Yeah, exactly. So you need to revisit this from time to time. So basically, the plan for today is to handle steps 1 to 3 of this life cycle, and we're thinking, if this is a success, and if you like what we are showing here, we'll go into step 4, deployment, and step 5, maintenance, in another session a little bit later, maybe in 2021. Okay, so I'll move on to the next slide. Okay. All right, so yeah, I am going to move on to the next slide, and the next slide is business problem definition. So we're starting at the very beginning. There's a decision to implement machine learning. You're the manager or project manager, and you're in charge of actually, making sure that there's at the end of the day, a business profit from this machine learning solution. So how do you go about that?
From my perspective, I very like the top-down approach. It means that from my perspective, business context is a crucial part to understand. We need to know what the product is, how the product works, how user journey looks like, how the data flow looks like, because this is very, very important before we even start the analyzing or building the model, right? The next step will be to define the metric, the technical metric that will be used to build the model, and this metric should reflect the business goal. And here is a crucial part for you, for project manager, because product manager is a person who will map the technical world to the business world, who will keep the vision of the end solution and how it should work and look like. This person at the end is also responsible to make sure that the technical success means the business success as well. And here I have an example. We had a project where, of course, we had lack of project manager engagement. The goal was to gain the knowledge about the business and build the model better than statistical approach that was already implemented on the client side. We did it. We were really excited about the results. Of course, clients accepted everything at the beginning: concept idea, data formats, result of model architecture, and so on. And then clients decided to move this model to the production, and he found out that it's not applicable. The data format was totally different on user interface side, and it wasn't possible to apply the changes to the user interface, because the business assumption was that we are not going to show to the end user that we are going to change anything. So at the end, we had to change the whole solution twice. Of course, at the end, the time needed to build the model was longer than we expected, and the end final result was not good as it could be. So the lesson learned from my side is that the PM engagement is really, really important to keep the vision how it should work on the end.
Okay. You know what, Łukasz, we got a question here that I think would be good to tackle right away. Marcin is asking here, how do you know, I assume in this case, that it's the model that stopped working and not that you over-learned it? I assume Łukasz clicked something that made him leave the presentation for. Yeah, okay. Welcome back. Was it such a scary question, or?
Yeah, but I had to think a moment about that.
Okay.
No, honestly, no. It was only the technical issue. As Willy said, we need to implement the monitoring, and the monitoring, we are all the time comparing, for example, the ratio about the labels that the model is predicting. So when we want to predict whether the user is women or the man, female or male, and we see that after 3-4 months we have only one class that wasn't the usual case when we started, we see that something is wrong, and we are looking to go deeply into this problem to verify whether there is something wrong with the model, or maybe our behavior of our user is a bit different, or maybe we have another group of user than previously. Usually the monitoring is the crucial part, and this is the first step to find out that something is wrong.
Okay, so Marcin, I hope that answers the question. If not, we can go a little bit deeper into this as we move on. Okay, so well, Willy hasn't added anything to this part yet, so what would you add?
Yeah, so briefly, I fully agree with Łukasz that the project manager should be involved from the start. That's very, very important, because basically that's the moment where we need to define what is the business problem. And I would just like to emphasize one particular point, which is this question of technical metrics and business goals. That's the moment where we need to define as a team, both the project manager and the technical team, what means that the project will be a success. When are we done? And the right way to do this is by having some metrics. So, and please believe me, quite often that's the difficult part at this step. To understand fully what we are really looking for, and to define some goals. Just to give you an example, we do have a problem at Egnyte where we try to predict if a user is maybe downloading too much file or in a way which is not normal. Now the question is, how do you define a normality? And we spend a few weeks defining what it means to be not normal. Does it mean that you download too much file from a bad location, unusual location? What is unusual location? From weird times of the day? And just specifying how we will measure the model is an important effort to be done here. And if we don't have this, then we are not able to answer the question, did we succeed in building the solution that we are supposed to build? And only business can give us the answer to what is the problem we're solving.
Yeah,
so that's a very important point here.
So, yeah, the way I see this is, if the machine is the element that's learning here, it's the business that is teaching it what it should look for, right? And sometimes that's the most important part, to actually establish these goals, as you just said. So these are our key takeaways for this stage. Engage the project manager as soon as possible. Take the time, as Willy just said, it can take weeks to really understand the business problem, for each functionality. And as Łukasz and Willy both mentioned, it's important to define technical metrics, but also connect these to the business goals. So it's it's connecting both worlds, as Łukasz mentioned. And yeah, shall we move on to data gathering, or do you want to add anything more here? Yeah, I see you nodding. Let's move on then. Let's keep it moving because I see more questions rolling in. Marcin, I see your second question. If you don't mind, we'll do it during the Q&A session if time permits. All right, so data gathering then. After the business problem definition, let's talk about a little bit about data. As you can see on our roadmap, there's 3 points about data, which really underlines the importance of having the right data and having it properly worked on and prepared for the model. So let's start with gathering. What would your advice be at this stage?
Well, if you want to teach a model, basically by providing data, you need to have the data. That's an obvious statement, right? But quite often it can be very challenging. So one way to obtain data is historical data. So if you got the luxury to have the historical data, then I would say that's the easy path, especially if these are data coming from the production. Now, sometimes you don't have this. So what can you do then? I'd like to mention 2 different approaches. One could be just to build your own data. So you can create synthetic data, right? The one artificial data. And here the trick is to try to have this artificial data that will be as close to the one you might observe in production as possible, which is quite a challenge usually. Another approach will be to reach for public data set. So there is quite a lot of data sets which are available. Just to give some example, at Egnyte we deal with mostly business data. So it's quite difficult to find this public data set containing business document, with one notable exception, which is the Enron data set. So as you might remember, Enron had some major legal issues as a company, and because of this, all the emails, including the attachment, have been given access to the public. So that's the type of document that we also reach sometime when we need to train on data that are publicly available. So that's the 3 ways that I'm thinking of about gathering the data we need. And if we don't have the data, we cannot train anything. That's simple.
Okay,
Yeah.
so that's pretty simple.
That's true, and that's also the reason why we, as a software house, usually when we talk with the client, we usually talk with the client that already have the data. However, it's not always, but the first case I would say on my list is the internal data. However, if client don't have the data, if client doesn't have the data, we can help with providing the data strategy. So it means we can help with identifying the data sources. We can identify the data within these data sources that is valuable to the particular problem. If we don't have the data, we will have to build or to prepare the plan how to build the feature to collect the data that we want, that we need. And at the end, if there is the issue with the data quality, we can help to solve these quality issues and to improve the process of the data gathering. Of course, the next step is to implement all of these things by the client itself or together with us. However, one more time, this internal data usage is the most typical case for us. Of course, from time to time, we also use the public data, but rather as an enrichment for the internal data. So it means that we have both internal and public data. And here, the point that we should have in mind is that we always should check the license of the public data, because sometimes we are not allowed to use it. The last point is really rare in order to my experience, in order to my perspective, it means software house perspective, the artificial data, because it's sometimes or usually it's hard to prepare the good artificial data. I mean, we need to handle the ratio between the labels, so the column and the values that we are going to predict. We need to make sure that we have the same ratio between these values in the artificial data and in your real data from the production. We need to handle also rest of the columns and the ratio of the values in that columns, as well as the nulls in the whole data set, the missing value, and and much more data characteristics. So this artificial data is rather the rare case on our side. No.
Yeah, it sounds like it could be risky to use it, right?
Yes, if it's not correctly prepared, then it's for sure risky.
Just to give you an example about one case where we've been using synthetic data, we wanted to build a classifier that detects automatically that there are fingerprints in some documents. And by fingerprints, I mean the real one with the thumbs and the other on the fingers.
Oh, okay.
Like, scans of forms with fingerprints. You cannot find this kind of document, either as public documents or from your customers. The customers won't give it because this is extremely sensitive data. So what we end basically using a public data set that contains a bunch of fingerprints, like a few thousand data fingerprints, and when we create a data set by just pasting the pictures of the fingerprints into some other documents, and that's the way we built the data set that we used to train.
Okay. So you like artificially inserted these fingerprints on some documents.
Exactly.
Okay.
Because that was the only way to have some relatively large data set that we can use to train.
Right. And in a way, here you use both, right? It was a public data set of fingerprints, but you use it to build a synthetic data set.
Exactly.
Okay. We have a question here coming in from Dominique. I have to admit that I don't understand all of the questions, so I'm just going to ask it to you guys. He mentions, he asked, how about few-shot learning strategies such as metric learning? That might be helpful in some specific cases. So what's your take on this?
Well, I will be very brutal in my answer. I'm still looking to see some few-shot or zero-shot strategy that works on production with real data. I've seen a lot of different papers promising a lot of things. Every time we check it for certain types of problem we try to address, it always fails at the scale that at least we need to implement this kind of technique. So there is a lot of promises, but currently I don't think that these techniques are already ready for production.
Okay, how about that for a short and simple answer? All right, so, all right, I suppose that covers data gathering, unless there's anything else to add here or add to the question that we just got. Okay, let's move on then. A lot to cover, like I said, and as you can see, some questions are rolling in, so I want to make sure that we have time to address these as well. So data gathering is just the first step. Then you go into cleansing and transformation, a step that at first sounded very mysterious to me personally, but as we were preparing for this, it's actually a very important step. So let's get right into it. How do you approach data cleansing and transformation? Why do it? And as a manager, what questions should I ask about this?
Yes, so that's really good questions to think about the general aspects. So here I would like to repeat that the business context, from my perspective, is really important, because if we don't have the whole picture about the product, user and user journey, we are not able to understand what we see in the data, right? So we need to have all of these aspects of the business knowledge. And also here, the role of the PM is really important to be a partner for the data team, for the machine learning team, to provide insights, or maybe to provide the information with whom we should talk to understand better how it works and what we see in the data. Because when we are talking about the product, we know that the product we have a few years of the maintenance. We have a few new features. We have a few features have changed. So it's also related to the data that we have in the database. At the beginning, we can have totally different values or even type of the values than in the last years. So it's really important to engage the product manager. And this is really important because the project manager also can have found some insights based on the data analysis that maybe he wasn't really aware of. Of course, this step is usually it's time-consuming, and trust me, there is a lot of different problems. There are a lot of edge cases in the data, much more common than we think. Another aspect is type of data. If the volume is really large, we need to use distributed processing, and also required to use the dedicated frameworks for that, and the time needed to set up the processing also will be longer. And the third option, I saw the companies, I had the possibility to work with the companies that weren't aware what they're collecting. And honestly, when I asked, what does it mean, what the data, what are related to they said, 2 years ago, there was a guy that left the company, and from that time, nobody touched it. So honestly, we don't fully know what we have there. So you need to analyze, and please prepare the summary on report, and then we can talk. Maybe somebody will know something about that. So this kind of problem also will result in the longer time needed to spend on that. And exactly that's the reason why the product manager is so important, or general the discussion and knowledge sharing with the business people is really important on that stage.
Yeah, I'd just like to add that from what I've seen in-house here at Egnyte, quite often this is the phase where the PMs are usually frustrated. The product managers saying this, if you look at the plan, how we want to execute a given machine learning project, they will look at this phase and say, okay, so you're basically processing the data. What do I have from this? What is the business value here? And they often consider this as a cost, right? We just spend some time just looking at the data. While in reality, what happens often is that when we do the analysis, we are able to come back with some questions about the data themselves. Like we identified something weird. There's a group of users that behave in a not normal way, or there are certain documents which are strangely structured. And this quite often is the beginning for the PMs of, thinking about new features about a case that they didn't identify before. And between us, I'm not surprised that they were not able to identify this kind of cases. If we analyze the data of all our clients at Egnyte, I'm talking about 16,000 companies, some of them having like 500 million files. I don't expect the PM to know what's happening in every corner of the data, right? Mm-hmm. So when we do this cleansing for them, for the PM, this can bring some real value. But the frustration is often there, so we need to communicate with the PM to explain them what we are doing.
Okay, so it's not just processing the data, and actually there can be insights drawn from this cleansing process.
Yeah. It's
okay, I see.
A bit of both.
Okay, great. So, Łukasz, anything to add, or shall we move on? I'd like to keep it moving if possible.
Yeah. Only I have one example of the project that we had. The general assumption when we are going to analyze the data is that the null represent the missing value. And we had the project where we decided to remove the rows with the missing value with the null in the column, call it event type. And this column was the most important part of the whole data set. But fortunately, PM checked it, verified our general approach, and he provided the insight that no, this time it's not the missing value, it's the really unique case that we had some time ago. Currently, we don't have this case, but we need to take care about that and process it as well. So this is the real example how important it is to have some feedback from the business side, from the project manager, especially when we are going to transform the data, right?
Yeah. To me, that's a crucial example. It really shows the role the PM can play here, the value that they can actually bring to this project. Because if they hadn't checked it, then a lot of data would be lost, and the resulting model probably would not be accurate, or would not be as accurate, right? Exactly. So I think one of the additional takeaways for managers here is that don't be afraid to get your hands just a little bit dirty. Just to delve into that data and to verify, like you said, verify the approach, right? So there needs to be a conversation between the manager and the engineering team, between the business side and the technological side. That's something that we will basically mention. Okay, so after cleansing and transformation, another stage on our roadmap that might be just a little bit mysterious sounding at the beginning is data annotation. So what do we understand by that, guys?
I'd like to take some analogy here. Imagine you are learning a kid to speak. So what you will do basically when something will be said by the child, then you will provide the right answer. Like, it's not she do, it's she does. You was, no, it's you were. And basically giving the right answers. So every time there is something that is produced by the child, if I can say so, you will take a look at what is the expected correct answer, and you will provide this to the child. Well,
yeah, as a former English teacher, I have to say I'm very familiar with that example. Yeah,
I suppose so. As a father of two, so do I.
Yeah.
So a model is basically like a child. We need to give some example, but we need to provide the right answer. Say, think about classifying email like spam or not spam. What you will do basically is providing a lot of emails, but for each email you will say, oh, this is a spam or this is not a spam, so that you can correct the model. So that's what basically annotation is about. It's about having the right answer when you provide some certain examples. Now, this is not always easy to have the right answer. Even if you gather the data, to be sure how the data should be classified or what kind of prediction you should make on it can be quite tricky. Just want to give you an example. We had a problem which consists basically, we would like to identify all personal names in files that we have. And because of GDPR and this kind of regulation in place. So how do you build a data set of documents from which you know where is John Smith and all the people possibly available here? So what we did basically, we took the Enron data set I mentioned before, and we started to do inside within the team, trying to look at the files and trying to figure out, oh, from this place to this place, there is John Smith, etc. But this does not scale. So here, in order to move this faster, we reach for solutions like the Amazon Mechanical Turk or the other solution like Appen that do this annotation for you. So there will be a bunch of people basically that would take the piece of document you are showing, and they will give you the right answer. Like, here is a personal name, or on this picture there is a cat, there is a dog, etc. And the way we did it, we just put, if I remember correctly, this was about 5,000 pieces of text. We put this into the Amazon Mechanical Turk, and 20 minutes later, everything has been annotated. So it's extremely efficient. So if you can do
20
this...
20 minutes?
Yeah, 20 minutes. Well, absolutely amazing. Okay. So if you can do this, that can be a way to have rapidly a data annotation. So knowing the right answer for certain data you want to use to train.
Okay, all right. So it's I suppose it also depends on the volume of the data, right? But if the volume is quite large, then you need some outside help to to move your project forward in a timely fashion.
Yeah, usually you need quite a lot of data to train. Even if we hear about these few shot learning techniques or zero shot, in most of the case you still need a few thousand examples to train something that makes sense.
Mm-hmm.
So it can.
And how did you deal with cases, for example, like what is the effectiveness of Mechanical Turk in terms of accuracy? What if they mislabeled some document?
Yeah, I think you touch a very important issue with data annotation, which is the quality of the annotation. So here, there are different techniques, but the general idea is that you don't want to rely only on one human giving you the right answer, because human can be wrong, they can be tired. So what you usually do is you give the same piece of data to 2 or even better 3 persons. And then you can just take the majority of the answer and you assume that most people will give you the right answer. So that's the way usually you annotate things, by providing the data to 3 persons or more.
Okay.
That's a very important point indeed.
And still it took 20 minutes. It's very impressive. Łukasz, yes. What would your tips be in terms of data annotation?
Yeah, I think that this is really important what Willy said, and those kinds of services are really, really useful. However, it's not always possible to use them. For example, if you need to handle the sensitive data, we probably cannot use those services. So we have, I think, two alternatives. One internally, second externally. Externally, I mean to hire an external company because you are able to negotiate the contract with that company. So this is kind of solution. However, you need to spend some time to find out the proper company, to find out the agreement on the contract, to establish cooperation, to introduce business context, you need to reserve some time to be available for them to answer some questions. And at the end, you need to probably as well double check the annotation quality. Of course, in the meantime, your team can be focused on something totally different. The alternative is to do it internally. As Willy said, for example, you can build a dedicated team for that, but it's hard and manual work, and nobody wants to do that for the longer time. So I saw in my experience one really clever solution. The company decided to build internal platform, web application that were available for the whole company employees, and they incorporated some gamification features, and top 5 annotators won some gifts. So each particular employee that started cooperate with them, started trying to win the gift, spent in general less time than the dedicated team, that each member from the dedicated team, and at the end they were able to annotate a lot of data. They used the trick like Willy said, so each row, each case was sent to at least 3 people, so the quality was always really, really good. However, at the end, you need to think whether you can share this data with the whole employees in your company, right? At the end, you need also to spend some time on building this web application, but if it's not one-time problem, you can reuse it. So it can work. It's really smart solution, and potentially there are probably a lot of more ideas how to deal with it. But yeah, it can be really time-consuming and long process to get the right answer for your data.
Yeah, that example is fascinating to me because you can always count on people to try to get into the top 5 for anything, basically. So gamification can really work here. And also another part that's fascinating is that, in this particular case, the company built an app to annotate the data to build another machine learning powered app, right? So yeah, it's very interesting to me. I just wanted to clarify one thing that we have on the slide here, because we have these takeaways. The term ground truth is mentioned here. So if I'm understanding it correctly, ground truth is basically these correctly identified cases, right?
That's the correct answer.
Okay.
So if I try to classify spams and no spams, the ground truth is, yeah, the answer. Is it a spam or is it not a spam?
Okay.
That's
yeah, and you need to
to
define that for your data set.
Yeah, and one other thing I just want to add, this is the second point here that we didn't touch, I think, is that in certain cases, especially if we try to predict things in time, then we don't need human to annotate. If I want to predict my sales for ice creams for the next month, if I come back in time, I can try to predict being in January, what will be the sale in February. But being today, I know already the sales for February. So I know what should have been the right answer. Right. So for this kind of problem, the ground truth is already available in the historical data.
Okay, right. So that's another thing to keep in mind. So, you can see all our takeaways on the slide here. We'll move right into model training next. And I just wanted to mention, because, I'm trying to stay conscious of the time, we do have an hour slated for this. So we'll get into model training. Model testing is up next, but if you find people watching have any questions, that would be a good time to start asking them. Depending on whether we have a lot of questions, we'll move right into the Q&A session. If not, we might manage to cover model testing. Either of you, do you have a hard stop at the 1 hour mark, or can you go a little bit over? Okay, I can see a lot of people are still watching, so we'll probably go a little bit over time, try to cover as much as we can. Let's get into model training then. What is this stage about, and how do you approach that as a manager?
Yeah, so from my perspective, the first stage of the model training is usually research, and this is really important. And it could be a bit different than what we see in the web development or mobile development or any other development. We need to find out what are currently the best performing algorithms in the area that we are going to work with, the problem that we are going to solve. Maybe there is already a pre-trained model that works very, very well and could be applied to solve our problem. Maybe there is a dedicated library that fits very well for our purpose. We need to find out also the alternative approaches. For example, and when we are talking about the deep learning, we will think about the alternative architecture of the network and so on. And this is the first step. And the second step is really important for you, for project manager, to make the boundaries of the project. So I mean, we have some ideas after the first stage, and here we need to decide which of them we are going to test and which of them we are going to reject. For sure, initially reject. Maybe later, if we have more time, we can back to them. However, it is important because if the ML team have 1 month to research, they will spend 1 month. If they have one year, they will spend the whole year. If they have 2 years, they will spend 2 years on research. So this is really important for project manager to think about the budget, the whole project timeline, and how many time we have for this particular part, and decide together with the team which part we are going to test and which of them we are going to reject at the moment. Here, I think that this is also a place where the project manager will touch a few technical, really specific words. To mention only a few of them, overfitting. This is when the model fits very well to the training data, but for the new or the test data, the accuracy is low. Or cross-validation, where the team is working on how to split the data to the training and the test set. So it's not important for the project manager to understand deeply all of them, but the crucial, a few of them that are the most important is good to know, because they may impact on the general time, how long we will test it, and which approaches we are going to check.
Okay, so for example, as a manager, if I hear my engineering team say that the model went too far and it's now overfitting, that's not something I want, right?
Exactly, and your team should propose the strategy to omit it, and then you should talk with them what are the results.
Okay.
Are you sure that model works very well, not only for the training data, and then they will provide you information. Let's check this diagram. We see here that the model is really well performing also on the test data, on the data that wasn't used to train the model.
Okay, so the overfitting problem then is fixed.
Yes.
Okay, so that's one word to keep in mind. Willy, anything to add here?
Well, I will be fully aligned with Łukasz on this, let's say, a budget approach. Like, as a project manager, you need to think about how many time you want to give to the team, how many resources. And what Łukasz just mentioned, just to give an example, last week we built one model using a few million documents, literally a few million documents. And this whole training step took around 1 week on multiple machines. So, there is no limit here. So, but if, as engineers, if we have the constraints, the boundaries, okay, we got 2 months to train the model, then we will adapt our plans, obviously. So that's, I think that's here a very important thing. Now, how we do this, and I've seen a question by Piotr about explainability. And the way we might use explainability while training, I would say that depends on the type of problem we do address. There are some other address where we might reach for feature importance analysis, but there are some others where we already have plenty of ideas and we just need to cut to the one that we think as engineers could bring the more value and can be the most efficient. So there are different approaches here. Explainability, from my expertise at Egnyte, I see more as something that can be useful for the customer, so that we can provide a reason for a certain prediction, for a certain classification. Yeah. But again, coming back to the main point here, we need to work again with the PM in order to know how many time we have, what is the budget, can we use 600 machines or just 2, and for how long, right?
Yeah, so I mentioned before that there are some aspects of machine learning projects that make it different from software development projects. And here is one crucial difference. At this model training stage, it's not how long is it going to take, it's more like how much time and resources can you afford to spend on this, because you could spend a lot. So it's all about boundaries here. And I imagine the manager here needs to be a little bit assertive and set some clear boundaries of this is the deadline and we have to meet that, right?
Exactly.
There's another point here that mentions taking into account the duration of a single iteration or epoch. And here's another word that I think it would be nice to explain before we move on.
Yes, so the word epoch can be quite useful for a project manager if you don't know this word already. The idea of epoch is that when we train a model, we'll take the data we have and we will put this into the model. And then the model will learn from this data. But it's, again, the analogy with the kid is still valid. As you know, if you have some children, you need to repeat yourself a lot. So here what we will do, when we give all the data, that's one epoch. And then we will repeat this, giving, again, all the data as examples. So that will be the second epoch. And why it's important is that if an epoch lasts 20 minutes and your team plans to have, let's say, 20 epochs or 200 epochs or 2,000 epochs, you can have some estimate of how long this will last. So the question of, do you know how an epoch lasts and how many epochs do you have planned, can be very valid from the perspective of a project manager.
Okay, because then they can estimate more or less when the training might be complete.
Exactly.
All right. Okay.
Yeah,
anything? Yeah.
I would like to add something to the questions from the Piotr.
Sure. Let me pull it up again. Here it is.
I saw an example where we had to use a specific algorithm. Particularly, we had to use the decision trees to make it possible to explain the final result. It was related because of the industry. It was the finance industry, and by the law, we were obligated to explain our decision. So yes, sometimes it's really important to have this possibility to explain the result of the model. But I would say that this is or industry-oriented or the client-oriented. Sometimes the clients also would like to know that. And usually we check the feature importance, as you mentioned. Usually, as Willy said, there is also a space for the business assumptions. So this is something that I saw that we need to talk with business, because business has some assumption and we need to verify it. However, even if we think that it makes no sense, we need to show that to the business. So from time to time, it's really important to think about explainability of the model. Sometimes, especially when we are using deep learning, it's harder to provide this one. So in my opinion, it's really unique about the case that we are going to solve and the industry and the client needs.
Okay, Piotr, I hope that answers the question. If you have any follow-up questions after that, go ahead and ask. And while we're getting through the backlog of questions, there's one that I still have here from Marcin. We were talking about, well, his first question was this, right? How do you know that the models stop working and not that you overlearned it? I suppose here we could talk, would that be related to overfitting, yes or no?
To the second part of the question, probably yes.
Okay. And then the follow-up question from Marcin was, are there any tools for automating that kind of monitoring? So are there any recommendations there?
There are tools. I'm not sure if to automate, for sure to monitor the results, the prediction, the class. But I think that this is a good question for the next webinar, right? Because this is in the part of the maintenance. that we would like to cover during the next time.
Right. So basically the question skips right into step 5 of our machine learning life cycle. And we're still at step 3 and not even getting through all of it because we're almost at the 1 hour mark. So I'm not sure if we have enough time to go into model testing, which we were planning to cover, because on the other hand, we also want to answer your questions. I think we got through the whole backlog of questions though. So, well, here we have to decide. Do you think we could do model testing in a nutshell, or should we leave it for next time? Because our takeaways from this are basically what you can see here, right? So can each of you say like 3 sentences and we'll be done with model testing, or is that not so simple?
We might give some insight about this, but I think from my perspective, this is one of the most important steps when we are implementing some machine learning model in production. So we can go very fast on this, but I think this requires some more serious treatment. So
sure.
If I may just take this one in, I will try to do this in less than 1 minute.
Yeah, go.
So first, if you want to test if your model works, you need to have the metrics defined before. So that's one thing we defined during the business problem definition. But if you run a lot of experiments, it would be difficult to trace to keep trace of all the results of all the models you're building. So that's why tools like DVC or weight and biases can be useful to keep trace of all the experiments you're doing. About all the different aspects, this is related with the definition of the metrics we defined before. This is where they are important. The last 2 points on the slides is basically about the idea that you might think that, yeah, we didn't reach the perfect model yet. Well, there is no perfect model, at least in machine learning. This does not exist. Machine learning is statistical. So basically, you will find models which are giving the correct answer in 95% of the case or 60% of the cases. And if you understand this, then the next extremely common error with consists in picking 1 or 2 examples, running this through the model and saying, you know what, it's not working, so the model is not working. That's not the right approach. If you take 1,000 documents and you put through the model and all of them are wrong or most of them are wrong, then you can be sure that the model is not working. But cherry picking, so picking just 1 or 2 examples and testing with this, is not correct. That's also a big difference between classical software engineering and machine learning. In software engineering, you can write tests. Like if I give -1, 0, or 10,000, my calculator should behave this way or another. For model testing in machine learning, this is not the way you do it. You do this statistically with a lot of examples. And I'm probably after 1 minute.
Yeah, that might have been 2 minutes, but I'm glad we got that in because for me personally, that's one of the big takeaways, that the model is never 100% accurate. Łukasz, do you mind if we move right into the takeaways from the entire presentation? No. Okay, because time is a little bit tight. I know some people have hard stops here, and I can see some of you are moving on to other things. Thanks for joining us. Sorry. Next time we can start with model testing. So here are our key takeaways. A lot of these points have already been mentioned, that you need to have the right business context to have the right solution. As a project manager, I think as ever, right, you need to be focused on the business goals. You're the one who's in charge of that, in charge of keeping everything connected to the ultimate impact for the business and ultimately to getting a positive ROI on this investment. Now, I think this next part is yours, right? Really, it's okay to have doubts about what can be achieved, but it's wrong to go without metrics, right?
Yeah, what I meant here is that even if, let's say, you built an anomaly detection system, it's okay to say, I don't know if I would detect 1 out of 10 million or 1 out of 2 millions at the beginning. That's okay if you don't know it, but it's not okay if you don't know what is that you're trying to detect. So if you don't have the goal for the metrics, that's okay. We will talk about this during the project. We can discuss this between engineers and product. But it's not correct if you don't know what will be the metric for the success, what you try to achieve. That's the point.
Exactly. And our last takeaway, I think that was quite clear from the amount of time we spent talking about data, but it's really important to have good quality data. And it really influences the quality of the ultimate model. And I think, Łukasz, some of the examples you mentioned here really illustrate that fact, right? All right. So that takes us through the whole presentation. Sorry for going a little bit over time. And now, as promised, the Q&A session. So we have a little bit of time to answer your questions. We're going to spend just a few seconds here waiting for some of these questions to roll in. There's a little bit of a lag between what we're saying here and you getting this. Simon here says, oh, I'm going to highlight this comment. Let us see it. Simon here says, very good presentation, guys. So you can be really proud of yourself here. Thanks, Simon, for that comment. Yeah, we also accept praise and compliments. So go ahead and shower us. Right here.
Especially from Simon, yeah. Especially from Simon.
Okay. Yeah, we got another comment here saying very nice. Not a lot of questions. I'll be honest with you guys, even if there were quite involved questions, we wouldn't have much time to cover them. But get in touch with us, you can reach out to us on LinkedIn. Or if you leave a comment under the presentation on LinkedIn, if you leave another comment on YouTube, we'll get back to you and we'll try to get you answers for your questions. Now, the final slide, you were expecting this a little bit, just 2 sentences about Egnyte and SDX Next. I think it's only polite to let Willy start as the guest here. So what would you like to say about Egnyte? And I heard you have some recruitment going on?
Yeah, actually, we got, I think, 2 open positions that can be interesting for the people attending this webinar. So the first one is for the product manager. So if you're more on the product side, I would suggest you to have a look at our career website and take a look at this particular job position. And also I'm recruiting for my own team, some senior machine learning engineer. So if you're interested in doing some stuff at scale with, again, a lot of data, then you're very, very welcome. Especially if you are very fluent in natural language processing, then I'm especially interested. As you can see on the slide, we do have a lot of customers, some of them like Red Bull and Yamaha, which are here reminded on the slide, with a lot of users and a lot of files. So when we talk about scale, we talk about real large scale.
Awesome. Okay. And just 2 sentences about us at SDX Next. Łukasz was, very open about the fact that, yeah, we help other companies with machine learning. We help other companies with software development in general. If you need a product built using Python, using JavaScript, if you need product design, or if you need DevOps, or, well, basically end-to-end solutions when it comes to building software products, we're here for you, and you can reach out to us at sdxnext.com. And, well, join other clients of ours like Decathlon, Unity, and MasterCard, and we can help your product become a reality and just get you more development capacity. Łukasz, do we have any recruitment we should mention here by any chance?
Yes, of course. We are recruiting for data engineers and machine learning position as well. Also seniors, 1 and regular 1. So feel free to contact us. Feel free to reach out us after the webinar. Okay,
great. So that was it from us. Definitely more to cover when it comes to machine learning and when it comes to the machine learning life cycle that we showed you before. We hope you liked the presentation. Feedback is very, very welcome about all of the aspects. Leave us comments. Be nice, be merciless, whichever. Everything is better than just not sharing your thoughts. We want to know what you thought. Thank you again, Willy and Łukasz, for all of the work that we put into this presentation before and during the presentation. And, well, all that's left, I suppose, is to wish all of you guys and gals tuning in a very nice day.
Well,
say goodbye, guys. I'm going to click end broadcast now.
Thank you very much.
Yes, thank you very much for having me, and thank you very much for attending the webinar today too, and have a nice day.
Yeah, thank you so much, and we'll see you at the next one.